Establishing a permanent human presence on Mars presents a myriad of technical, physiological, and logistical challenges that go far beyond those faced by missions to the Moon or any manned orbit around Earth. The first major hurdle is the distance involved. Mars is, on average, about 140 million miles from Earth, and travel to the red planet could take anywhere from 6 to 9 months depending on the positions of the two planets and the technology used. This long travel time introduces significant risks, including exposure to cosmic radiation and the psychological effects of prolonged confinement in small spaces. Once on Mars, astronauts will have to deal with a harsh and unforgiving environment. The Martian atmosphere is only 1% as thick as Earth's and consists mostly of carbon dioxide with only trace amounts of breathable oxygen. Temperatures can swing from 70 degrees Fahrenheit during the day to minus 100 degrees Fahrenheit at night. This extreme environment necessitates the construction of robust habitats that can support human life by providing adequate shielding from radiation, maintaining pressure in breathable air, and regulating internal temperatures. Another challenge is the need for self-sufficiency. The vast distance from Earth means that resupply missions would be infrequent and costly. As a result, Martian colonists would need to be able to produce their own food, water, and oxygen. Water ice exists on Mars, but it must be mined and purified. Similarly, food production would require significant amounts of water and nutrient-rich soil, which Mars lacks. Techniques like hydroponics or aeroponics could be employed to grow food, but these systems would need to be incredibly efficient and reliable. Energy production would also be a critical concern. Solar power is less effective on Mars than on Earth because of the greater distance from the Sun and frequent dust storms that can obscure sunlight for weeks. Nuclear power might be a more reliable energy source, but it brings its own set of challenges, including safety concerns and the need for significant infrastructure to manage waste heat. Healthcare is another critical area. The reduced gravity on Mars, which is only about 38% of Earth's, could have long-term effects on human health, including muscle atrophy and bone density loss. Isolation and the extreme environment could also have psychological effects. A permanent settlement would need to be equipped with medical facilities and staff capable of handling both routine health needs and emergencies, including those that might require surgical intervention. Communications with Earth would involve light-speed delays ranging from 3 to 22 minutes each way, complicating any interaction, whether for personal communication, scientific collaboration, or emergency support. The development of autonomous systems and local decision-making protocols would be crucial to manage these delays effectively. Another logistical challenge is the transportation of materials and equipment necessary for establishing a permanent settlement. Launching materials from Earth is expensive, with costs driven by the energy required to escape Earth's gravity. Technologies such as in situ resource utilization, ISRU, would be critical to reduce dependence on Earth-based resources, by using Martian materials to manufacture everything from building materials to electronic components. Legal and ethical issues also need consideration. Who governs Mars? What laws apply? How do we ensure that activities on Mars do not contaminate the planet in ways that would make future scientific research on native life forms impossible? These questions need to be resolved in international forums before permanent settlements are established. In summary, while the idea of colonizing Mars excites the imagination and could potentially safeguard the future of humanity, the reality involves overcoming monumental challenges. Each of these challenges must be met with innovative solutions and robust technologies that ensure the safety, well-being, and self-sufficiency of Martian colonists. As such, the endeavor to establish a permanent human presence on Mars not only pushes the boundaries of human exploration but also requires a multidisciplinary approach spanning science, technology, engineering, medicine, and ethics.